Hello class, welcome to another studies on linear functions. Today we are going to learn about modeling with linear equations, and that is about applying algebra to real life situations. Now let's see the introduction here. Many real life problems can be solved mathematically using linear equations. These models help in predicting outcomes and making future decisions. So linear functions also represent changes in relationship. And what we need to know is what is mathematical modeling. So when you talk about mathematical modeling, what does it mean? Mathematical modeling uses equation to represent real world scenarios. Linear models are used when there is a constant rate of change. So we've learned about linear equation uh, during our previous lessons. So if you've not done that, I will plead with you to go back to our previous lessons and learn a lot about the linear equation. We realized that during the studies, we analyzed and realized that linear models are used when there is a constant rate of change. Your linear models or linear equations or functions always produce a constant rate of change, and that constant rate of change is what we call the slope. It is helpful in making prediction and analyzing the trends of an activity. So let's move to the next one. Let's see an example here. An example is being attributed to smartphone sales. So this is a real world contents example that we are going to deal with it here. We have weekly price and sales data. So when we come to week one, we were able to sell 30 units of phones and the price is 800. Week 2, 40 units and the price is 700. Week 3, 50 units and the price is 600. Week 4, 60 units and the price is 500. So, what is the goal? The goal is to look at this strength and predict sales of price drops to 200. We look at the trend and predict sales of price drops to 200. So let's see the linear model for this particular expression or context. So the linear model is saying that n is equal to np plus c. This is the linear model. It is a linear model in the form that because there is a consistent change, a constant change between the price P in Ghana cedis and the sales N. Good. So for this linear model, N is the sales, P is the price, and the C is the constant, and it will be the maximum when the price is 0. So we choose 2 points here. The 2 points that we are going to choose will be 650 and 560. So it means that this 600 is the x coordinate, 50 y coordinate. This 500 is the x coordinate, 60 y coordinate. Then we are going to find this particular linear model. So we will use simultaneous equation to find the model. So we substitute the 50 and the 600 in the equation of the linear model at where they are supposed to be. And we repeat the same process for 60 and 500. Then we solve them simultaneously. So in terms of the simultaneous equation, we are going to subtract equation 1 from equation 2. When we do that, 15 minus 6 will give us minus 10. 600 minus 500 will give us 100 m. Then the c minus c is 0. So now our m will be equal to negative 0.5, where m represents the constant change in the price and sales of the phone. Then we can sub this into the expression the 60 and the 50 back into the expression, and also make sure we find C, and C will be equal to 110. So the final model will be equal to, N will be equal to minus 0.11p. Why? Because minus 0.1 represent the constant change that is happening between the drop of the sales unit and the corresponding price. So we have the minus 0.1 p plus 110. So when you look at this particular model, we can use this model to predict the future price, or we can also use it to predict the future sales. Good. So we have the C to be 110, which is the constant. And the constant, it means that the price here, the maximum price that we can reduce to is 110. So the maximum price, or sales rather, the maximum sales we can get up to is 110, because if the price becomes 0, the amount will be negative 0.1 times 0, then we are going to be left with 110. So let's see how we can use the model that we've got to predict the number of sales when the price is equal to 200. So the moment the price is equal to 200, we've learned about functions. So it means that the input value is now 200. So we are going to substitute the 200 into the function, and when you do that, the function will process everything to give us the number of sales. So if P is 200, we are going to get minus 0.1 times 200 plus 110, and the answer will be 90. So 90 smartphones will be sold at 200. 90 smartphones will be sold at 200, which means that we've used the model to predict future sales, future number of sales of what? Of the phones when the price is what? 200. Let's also understand the model that we just created. The slope of the model M is equal to negative 0.1. What is the meaning of the slope? That is a constant rate of change that is happening to the price and the number of sales. So for this slope, it is telling us that anytime there is 100 Ghana cedi drop on the price of the phone, we will increase the sales by 10. And it is true. It is true. When we drop the price by 100 Ghana per this rate, it is telling us that anytime we drop the price of the phone by 100 Ghana cedis, we end up increasing the sales by 10. Then let's look at also the intercept, C equal to 0. The intercept represents the maximum sales when the price is 0. The moment the price is 0, then the maximum sales that we can get is 110. That is what the intercept is being estimated to. Then we have negative slope implies inverse relationship. So when you have negative slope for a linear graph or linear equation, as we've learned previously, you are going to realize that there is a negative relationship between the input and the output, or there is a negative relationship between the x and the y, or there is a negative relationship between the dependent variable and the independent variable. It means that when one is rising, the other is falling. So look at the example that I just gave here. Anytime there is a drop in 100 cedis tag price, then it means that the sales is going to be increased by 10. So whilst the price is dropping, the sales is increasing. That is the meaning of negative slope of a linear graph. So it indicates the inverse relationship. So let's look at the graphical representation of the modeled, the linear modeled that we just did. We have the NP equal to negative 0.1p plus 110. So this graph represents the model. it is a straight line because the model was linear model, and we have all the points on it. So look at the point indicating the price and the sales. So this one is a linear model, a linear function, which the gradient is negative. That is the reason why you can see the line falling from the left side to the right side, which indicate the inverse relationship between the two variables, which is the number of sales and the price. So the relationship is just telling us that when the sales was 500, the price is the sales was 60, the price was 500. And the sale being 50, the price was 600. The sale being 40, the price was 700. It means that anytime you increase the price, you turn up reducing the sales. Anytime you increase the sales, it means that the price is also what? Reducing. They are inversely related. Good. So that is the meaning of a linear model being drawn on a graph sheet. So if it is positive, then the gradient is positive, then the graph or the line will be rising from the left to the right. If it is negative, then the line will be falling from the left to the right. So you can also see the alternative approach that we use here. We find the price difference, and the price difference in the sales is 10, and the gradient to be negative 10 out of 100, which is equal to negative 0.1 because it is reducing. Good. Let's move to the summary and class activity. So we have a summary to explain everything that we've just studied so far. So the summary here, we have a linear model help predict based on trend. So the trend will help us to make some prediction. A negative slope, as price rises, sales fall. So we end up seeing a negative slope, which indicate that they are inversely related. The two variables are inversely related. That is the price and the sales. So as price rises, sales fall. Validate models using known values. So we need to validate the model using known values. So we have an activity here. A product sells 50 units at 600 Ghana cedis and 70 units at 400 Ghana cedis. Form a linear model for this particular activity and predict the sales at 300 Ghana cedis. I will be receiving your feedback, and it will be very interesting to be able to know the kind of model you are going to write for the activity. So thank you very much for listening to this wonderful section of our studies on linear function. Don't forget to subscribe to Woodland High School Math Room, and for us to keep on giving you the best of math education at the high school level. God bless you.